Hello YouTube, thank you for tuning in. Remember to like this video and hit the subscribe button. In this particular video, we are still looking at how we can implement different programs in TIA Portal, that is by using ladder logic. And in this particular video, we are still looking at an application of a latch. And we said in one of our videos that a latch is a logic circuit that maintains a given logic condition until that logic condition is changed by an external source. So for example, you have a latch having set and reset. So when an input, when you set that set button high, you have an output. When the set button is set low, then you have a low output. So in this particular video, we are going to apply the same mechanism to design a program that is going to switch on and off a motor, and then also with a lamp involved. When the motor is off, the lamp is on. When the motor is on, the lamp is off. So the guiding question says, design a ladder logic program to control a switch, to control or switch on a motor and a lamp using two push buttons. When both buttons are high, the lamp is low and the motor is high. When either of the push buttons is high, the motor is still off and lamp on. When all the push buttons are off, the motor is off and the lamp is on. So you can see that here, the OR logic is the one that is switching on the motor. So let's right away go and see how we can implement this in TIA Portal Siemens. So we have already opened our program and we are going to right away go to create a new project. So we are going to call our new project, we are going to call it YouTube Push Buttons. So ensure that you have a computer that is super fast because this program is heavy. So now what we do, we are going to go to configure the device. So when you go to configure device, let's add a new device. So this is going to take us here on the devices that we can add, and we have controllers, HMI, but in our discussion, we are going to go to controllers. So let us pick schematic step 7, 1200, and we choose a CPU. Maybe let's choose this CPU. Make sure that the version is above 4. So 4.5 is good for us. So we add. So the CPU for the PLC has been added. And now what we are going to do is to right away go to the program blocks and we go to main so that we can write our ladder logic program. So we are here in our ladder logic environment. So we are going to use a normally closed, normally open contact to have a design of our push buttons. So I'm going to click here and put our output. I come here, put another branch. So I add a push button. Then I'm going to put an output here. Then when we come here, we are going to put a normally open contact. Then we add a branch. So on this branch, we add a normally open contact. Then we close up here. Then we come here, add another branch. And here we are going to use a normally closed contact. And then from there, we put our output. Then we come down here, we are coming here, we are going to add a branch. So we add the button here, I mean a normally open contact. We add another normally open contact on here, and then we close with an output. So the next step is to create tags, which we are going to put in here. We put tags and their addresses. Let's go to PLC tags and we show all. So since we haven't created them, let's create them. So there we have to put a push button, maybe one. We have another push button here. Put a push button, two. We are going to put a relay coil, one. We put a relay coil, two. We put another relay coil 3, and we are going to put a lamp here, and we are going to put our motor here. So this one is done. What we are going to do is to get back to our ladder logic program and start putting those tags. So here we have a push button 1, and this is going to have a relay coil 1. This is push button 2. We look for wherever it is. Come here, add relay coil 2, and this is going to be relay coil 1. This is relay coil 2. Come here, this is relay coil 3. Then we make this relay coil 3, and then the output here is going to be a ramp. This is going to be relay coil 1, relay coil 2. So what we are going to do now is to configure our PLC. So we are going to go to device configuration, and before we run, let's first check the protection settings. So I go to protection and make sure that here is not selected. So I press OK. I come here on the PLC. I check on security. I check on security, protection and security, and unselect this. Then we also give it full access. Then the other issue is us checking our PLC to see if our inputs have been put correctly. So when you check our PLC, we have the digital inputs, the push button 1, push button 2. You have the relay coil 1, relay coil 2, relay coil 3. You have a lamp, you have a motor. These are okay. Let's check. Okay, this is not right. So what we are going to do, we are going to change the addresses so that we have the output. So we come back here and make sure that we change the addresses here. So we are going to make this a true because we are using Siemens. We are going to use a true, but now let this become true 0 because it is our first output. Then this one becomes a true, and let it be 1. This becomes also a Q, and let it be 3. Then let this become a Q4. Okay, let it become a Q, but we are taking it to 4. We are also taking this to be a Q, and we are taking it to 5. So we can save that, come back to our device configuration, and check now. Our inputs are the 2 push buttons, and all our outputs are this side. So we have finished that. So what we are going to do is now to run this simulation and allow the system to configure itself. So what we are going to do, we are going to run a simulation. Let's come back to our, let's put our motor here because this is the output. Okay, so here, let's compile. After compiling, let's go to our CPU and let's run the simulation so that it can configure itself. So we start the search. So this is what is accessible. So there we do the load, consider as trusted and move. So allow it to compile the configuration, convert the ladder logic and all other programs into executable file. by the CPU. So once it is done, we do the loading. Again, we load now the configurations. Then we come here on action, we say start the module, then we finish. So here you will see that you have no errors. So once you have no errors, we can now put this CPU back at the normal size, whichever size you want. Then what we are going to do, we are going to go to our main ladder logic program, and to run this simulation, we are going to create a simulation table. So click on here so that you can create a simulation table. So wait for it to open, and then you create those buttons. So once it is done, you come here and create a new project. So we call it our simulation table for YouTube. Click on create. So you create a simulation table. So come back to sim tables. So when you create a simulation table, by running this program itself, the PLC sim, it will create the sim table as sim table 1. So click on sim table 1, then you come here and add on the components of your system. So we have a push button 1, we have a push button 2, we have a relay coil 1, you have a relay coil 2, you have a relay coil 3, you have a lamp, then you have a motor. So once you have created your sim table, it's time for us to simulate our program. So we come here, and what we are going to do is to click on monitor. First, make this visible. Okay, everything is visible. So we click on monitor and see that power is reaching this left power rail. So we go to our simulation table. So on this simulation table, we are going to make this. Okay, so what we are going to do, let's go to our push button and make them true. So we can see that this relay coil 3 is energized. So when the relay coil 3 is energized, we see it has a true here. So what we are going to do, you see, when it is energized, it means here, this one is a normally closed contact, and therefore when it receives a high, it will be open. So this lamp will not receive anything. So what is going to happen is that when I make this push button also go high, our lamp is going to be off and our motor is going to be high. So let us check our problem here. So we are saying that we design a ladder logic program to control or switch on a motor and lamp using two push buttons. When both buttons are high, the lamp is low and motor is high. When either of the push buttons is high, the motor is off and the lamp should be off. Okay, let us sort that one. Okay, when all push buttons are off, the motor is off and the lamp is on. Okay, so we are saying, let's make this off, make this false, and you can see that when all of them are false, we have nothing, but we have the output at this lamp because this normally closed contact is energized because for it will be conducting. So all of them are off, our motor is off, and the lamp is on. Okay, so when all the push buttons are off, the motor is off and the lamp is on. So when either, so we are saying either of the push buttons is on. So let us see what happens. The lamp goes off. This one is energized, this coil is energized, but power never reaches the motor and never reaches the lamp. So I think you can see how we can make this kind of a scenario. When you switch on these two push buttons, the motor is on and the lamp is off. When you switch off the motor, of course, when you switch off now these push buttons, you have this lamp high and the motor is off. So we are saying when you make all of them false, you have the lamp on. So this is what is happening. So ladies and gentlemen, that's how we can deal with this particular problem. Thank you so much for tuning in. See you in the next video.